an activity that we call the Metal Non-Metal Lab. And the first thing we're going to do is to look at a periodic table and describe where you'd find metals and non-metals on that periodic table. So the first one here, where would metals be located? And it may help if we put the stepped line that actually is the dividing line between metals and non-metals. And why that happens, you want to suggest something in terms of electron configurations and numbers of valence electrons. And so for the non-metals, the smaller portion on the right-hand side are going to be non-metals. And then finally, around the zigzag line, step line, we have the metalloids appearing. And in the lab, pause this to read it carefully and indeed read it a second time. Goggles, gloves, aprons, materials that we're using, use tweezers to touch the samples, the hammer, and disposal, still keep your goggles on all the time, and dispose of the liquids in the beakers provided. And if you're rinsing the well plates, hold them low in the sink in a gentle water flow. And what we're going to do is look at a procedure. And the first one is looking at brittleness and placing a fragment in a baggie and predict metals and non-metals will do when hit with a hammer, and what it is that determines the difference. And you're going to have to look at the bonding between the atoms to come up with that one. So you're going to hit the sample with the hammer. That's against a hard object. We used the bases of clamp stands to do that, and determine whether they're brittle or malleable. Do they bend? Do they shatter? Bending and hammering, denting is malleable. And here are the results. So you can pause this, you can come back to it and determine, help to determine which are metals, which are non-metals by this activity. And then station 2, 2 parts, appearance and conductivity. So what are the visual properties that make metals distinguish from non-metals, and are they going to be 100% on the criteria you give? And what's going to cause that visual difference? And you need to be very detailed in your description of each of the elements. A specific colour, so an adjective with the main colours, texture, shape, luster, etc. And here are the samples in the small weighing tray, and you can describe those. Some of them you may know the identity already, and that's okay, but others you'll use the experimental results. And the part 2 is conductivity. It's a conductivity meter which needs turning on. Use tweezers to hold the sample or hold the electrodes of the tester on the sample. And what are you looking for, whether it's a conductor or an insulator, and what causes a substance to conduct? So you're looking again there at really the electron configuration and the valence electrons. So here's a diagram of the conductivity tester, and you're looking at a red LED and a green LED and the on-off switch, and the 2 electrodes at the bottom both have to touch the sample. And there's a summary of what happens here. If they're both off, there's no conductivity. If the red is dim, you have very low conductivity, but worth recording. If the red's fully on and the green is from dim to brighter, you've got high conductivity. So again, you might need to keep coming back to this one to review that. And then you're going to look at the results of each one, the 7 samples. And the little glow around the LED, and in some cases not much of a glow, is telling you that you have conductivity and that light is lit. So this is A through D, and then we go on to through G, and you may need to come back to these when you're completing your table of results, looking at how you are labeling whether they're going to be metals or non-metals, etc. And here are some diagrams to show touching the sample with the 2 electrodes and looking at the pattern, but go back to the table which shows you what's happening. Then we're going on to station 3, reaction with dilute hydrochloric acid. Still keep your goggles on, and indeed gloves. Use tweezers to place a single piece of each element in separate wells in a well plate. And when you add the 3 drops of dilute acid, does a reaction take place? So what's your criteria for a chemical reaction occurring? And once you've considered that and answered it, what types of materials react with acids and which elements? And make sure you still have your goggles on when you tip the products into the beaker provided at the end of the experiment. You don't want all that cloggy stuff down the sink, please. And once you've tipped the solid material and the liquid out, gently rinse the well plate low in the sink. And here you've got some results, the bottom 2 diagrams. You're looking into the well plates. Not always easy to see, even in real life there. And so going to help you with 2 and say A and C have not reacted. Some of the others have or have not, and I think they're a bit easier to see as you're going through it to get your results from this one, and you can pause this and or come back to it. The final station is react with silver nitrate solution. You can use copper sulfate solution as well. Goggles, gloves, and care with the cleanup again. Tipping all the liquid out and rinsing carefully actually into the beaker with a distilled water bottle. Use tweezers to place a single small piece of each element in separate wells and determine whether reaction takes place when you add 2 drops of silver nitrate solution. And here are a set of results, and perhaps should have said this earlier, but it helps if you keep organized and put the samples in alphabetical order along the top, and you're only using the first 2 wells of the second row. And then add 2 drops of silver nitrate and leave it for a short while. Identify which have reacted. And again, it's not always easy. And here I'm giving you a little bit of help and saying B and C. Do I mean B and C? Some of B has reacted. And which of the others haven't? C hasn't. Okay, you're going to analyze your data. So from the hammer test, conductivity, appearance, acid and silver nitrate reactions, what are you going to head the 2 columns? So you can divide them up. Well, sort of given it away with the name of the experiment. So I've got 2 groups here. And so for each one, divide up which letter sample you think are metals, which are non-metals. And you can have an unsure category. And ditto for conductivity and appearance. And then for both 3 and 4, the reactions, which ones do react, which don't. So a summary here of of a table of results for each one of those. And see if you can classify each one of them from that table as a metal, non-metal, or one that doesn't fit into the two groups. Now why? What properties are distracting you from choosing it, something being a metal or a non-metal? And so you can put the word metal, non-metal, or metalloid, and then identify the element that's there. And some you knew, some you might have a little bit of difficulty with, but let me give you some hints. These are just in alphabetical order of the elements, not in alphabetical order of the letters of the samples. So you have to choose which is A, which is B from that list. And so you can pause that whilst you're doing that activity. And then going on, once you've identified them, where are they on the periodic table here? Do those positions agree with the classification of metal, non-metal, or metalloids? So you've got to pause, identify what A was, point to where it is on the periodic table, and then determine, yes, it's a metal, no, it's a non-metal, etc. And then one of the unknown elements you were investigating was carbon. It can exist in different forms depending on the structure it forms, the arrangement between the atoms. And these are known as allotropes. Several elements and compounds have allotropes, exhibit allotropy, and carbon includes diamond, graphite, and buckyballs, fullerenes. But just look at diamond and graphite, research the properties of diamond and graphite, and describe 4 properties for each allotrope. 4 for graphite, 4 for diamond. And how do the properties relate to the different uses of diamonds and or graphite? And you can see where the scores go on the activity. And in particular, explain which classification tests were best based on the data, the results that you had. Another activity, 10 items at home that are made of metal. Which metals are they? And sometimes they're alloys, mixtures of metals. But why were they made of those particular metals? And the individual metal that was chosen in particular. So you can sort of copy that table and extend it to 10 lines. And then for an idea here, looking at physical or chemical properties that applies in each of the labs, and you can either circle or just write down for 1, 2, 3, 4, and remember appearances, station 2, part 1, whether they're physical or chemical properties. And finally, many thanks to Washington International School, WIS Team Science, and Ms. Hager. Thank you.